the Earth's surface. So if we look at both of those, you can see solar radiation comes in, much of the heat is radiated out, with not very much remaining back here on Earth, whereas in today's greenhouse effect, with the enhancement of our own doing, much of that heat is trapped here, causing climate here to be warmer and global warming taking place over the entire planet. I should mention that global warming is over the entire planet, where climate is local. So, I mean, we have a local climate here today, which may be different from local climate where we were yesterday. Global warming is the entire heat entrapment across the entire Earth. So what are the potential impacts of continued global warming? Well, in the health area, weather-related mortality has increased. We've seen that particularly in areas like Bangladesh, where they've had many people dying of heat stroke and whatnot. We also see that our infectious diseases, malaria, for example, is moving into what were the temperate areas. We have cases in the United States, for example, in Florida. We now have some malaria cases developing there in the last 2 or 3 years. And those things are going to increase, or apparently are increasing already. In agriculture, particularly in the southern hemisphere, we have major crop yields decreasing, which is proving to be stressful on human existence. That is to say, they don't have the food that's necessary, etc. And irrigation demands are increasing, particularly in areas that were once semi-arid and are now becoming more arid. And we are using significant amounts of groundwater from our aquifers, which are not being replenished. Forests, we already see some changes in the insect populations, which are affecting particularly the conifer populations, the evergreen trees, in many areas of the world. And the forest health is being reduced. A few years ago in Kew Gardens in London, they had a major windstorm which took out many of their trees, and rather than replanting the temperate trees that were there, they're now planted trees that are normally found in the Mediterranean climates. And so instead of planting trees that they normally find in the northern tier of Europe, they're planting them from the southern tier of Europe. Water resources, water supply and water quality, and competition for fresh water are increasing worldwide, particularly in those areas where we have semi-arid conditions or overpopulation relative to the amount of fresh water that's available. Coastal areas, we already see that some areas are affected by increase in sea level, drowning parts of the coastal areas, and particularly when you have major storms, the storm setups bring flooding to coastal areas. In the United States, in the city of Miami, Florida, for example, during major storms, those areas are finding flooding in their streets. And of course, species in natural areas are being changed. There's loss of habitat. Peter talked about some of that already taking place because it affects the oceans as well as the land areas. And I believe he was talking about krill. Well, krill are dependent on ice because they feed off the bottom of the ice, and they're also part of the bottom, or nearly the bottom of the food chain for many areas here in the Southern Ocean. And as water temperatures increase, those krill are unable to survive under those conditions. So what are the things that affect climate? Well, one are the variations in part resulting from the positions of the continents and oceans. And you see each of the blue lines here indicates the time we've had glaciation on the planet. And in part that's contributed to by the position of the continents. When they were completely clumped together, as you see here, there was a major period of warm climate, quite hot. But when there were areas where there was least water, oceanic currents flowing among and around the continents, Those are periods of time when we have major glaciations in Earth history. So let's think about the Sun-Earth relations. There are three parts to this. One is the eccentricity of the orbit the Earth has around the Sun, and that varies in about 100,000 year increments. Secondly, the obliquity cycle. The tilt of the Earth's axis affects global warming, or if you want, climate. That's on a 41,000 year cycle. And finally, you have the precession of the equinoxes, which shift, as you can see here, on a 19 to 20,000, 23,000 year cycle. In the past, when all three of these have lined up, we've had glaciation over the last couple of million years. Each time all of those cycles were in line, in other words, if you had both this and one of these, all of that combined simultaneously brought about glaciation. So if we look at our influence on the atmosphere during the last 1,000 years, you notice that on each of these graphs there's a continuum of relatively stable production of methane in the atmosphere, carbon dioxide, nitrous oxide, and some of the sulfate aerosols. And then starting around the Industrial Revolution, you notice there's a dramatic upswing in all of these gases, as you can see here. So that today we have a situation where the atmosphere is significantly more saturated with carbon dioxide, methane, nitrous oxide, and some of the sulfate aerosols. What about ocean circulation? Obviously there's heat put in the oceans over here at the equatorial regions, this area over here basically. And then as it progresses, as those currents progress over to the polar regions, there's heat loss that takes place, and the cold water then sinks, mixes, and returns to the equator. Basically, the waters from the Arctic Ocean come down the North and South American east coast. They upwell in the Southern Ocean near the Antarctic continent, and then proceed to go around the Indian Ocean, the Pacific Ocean, and then come back up as part of the Gulf Stream between North America, South America, and Europe and Africa. So what happens in the north has impact on what happens in the south from the oceanic standpoint. Changes in that circulation, its chemistry and biology, can shift the balance that affects climate. Remember that the atmospheric system is dependent on drawing moisture from the oceans, so that depending on the ocean itself, whether it's hot or cold, or warm or cool, that affects the atmospheric circulation of the planet as well. What about volcanic eruptions? When you have a volcanic eruption, you have sulfur dioxide up into the atmosphere. That tends to reflect the incoming radiation from the sun. So that has a cooling effect on the planet. One of the best examples was the 1815 Tambora eruption in Indonesia, which caused worldwide year without summer. Affected crops all over North America, Europe, and also in the Southern Hemisphere. And that's taken place a number of times since then. Krakatoa, which you may be familiar with, that's a well-known eruption, El Chichen in 1982, and Pinatubo in the Philippines in 1981. All of those resulted in a global average temperature decreasing by 1/2 degree Celsius, or about almost 1 degree Fahrenheit, simply from those massive eruptions that took place. Land use changes. We've made a lot of land use changes as we have inhabited the planet and changed much of the forested regions into cropland, which has an effect on the amount of carbon that can be stored in the plant materials. more in the forests, less in the crop areas by and large. We've made cities out of areas that were originally forested, and the cities, of course, don't store the carbon. It's in existence. They create islands of heat. Your cities are your warmest sectors of any part that you're living in because they're building. So land use change is one of those, of course, is populations that are inhabiting rather than rural areas or the urban areas. At present, about 53 to 55% of the population of the planet is now living in urban areas. And those are creating heat islands because of buildings, industry, parking lots, roads, and the like. What about small particulates in the air could have either a warming or a cooling effect? And so if we look at the sulfate particles from the volcanoes that I was just talking about, that tends to reflect the sunlight or the incoming radiation, and that tends to cool the earth. Well, if we look at industrial production, the black soot from some industries absorbs the solar radiation coming in, and that, of course, tends to warm the earth. Clouds can do it either way. They can either cool the earth, depending on their density and altitude, or warm the earth. In the case of the light, high clouds, most of the solar radiation that comes in, much of it can actually be re-radiated out into space. However, there's a strong cloud cover that's trapped. It cannot go back out. The radiation comes in, the radiation going out is trapped by the low cloud cover. So the one tends to increase the heat of the planet and the other tends to cool it. What about amplifiers like reflectivity? Well, if you notice here, if we're dealing with snow and ice, as we will down in the Antarctic, somewhere almost 90% is reflected that is re-radiated, so that's obviously cooling the planet. If we talk about vegetation and dark soil, only about 20% is reflected, and over the waters that we've been traversing, only about 10%. So all of those have an effect on whether we have a global warming, that is to say the entire atmosphere of the planet is warming or cooling. So let's take a look at what's happened over the last 400,000 years. Over the last 400,000 years, let me step back a minute. We've drilled ice cores through the Antarctic continent, and we've done the same through Greenland. Both of those are areas with major ice sheets. And drilling through the ice core that we take out, in the ice, air bubbles are trapped. When the ice forms, the atmosphere that is existent at the time is trapped in air bubbles in the ice. And in the last 400,000 years, as we look at the air, the atmosphere of the time, we can tell you what the levels of carbon dioxide or other gases are. And the way we date that is because volcanoes have been erupting throughout that period of time, and layers of volcanic ash are in the ice. So I have a zone of ice. For example, this bottom row is empty here, that's pure ice. The next row, there are 3 folks in it, so I have 3 particles of gas that are trapped in the ice there, and so on all the way up. And in that way, if I look at carbon dioxide for the last 400,000 years in this graph, although we now have records that go back 800,000 years, you'll notice that the carbon dioxide levels were significantly higher in a variety of periods roughly 350, 325 sort of thousand years ago, about 225,000 years, about 125,000 years, and today. And in each of the times we had very high carbon dioxide levels, we had deglaciation, that is to say the ice sheets melted. And in between, we had glaciation, major ice sheets. And if we look at the last couple of 100,000 years in this zone, these are the glaciers that covered North America and Europe and parts of Asia during the last 150,000 years. And if you're familiar with some of these areas, depending on where you live, there were a series of glacial events that took place during that time. And then in the last 10,000 or so years, we've had major melting of that. And that's been reflected, as I say, in the levels of carbon dioxide that we have. We're currently up at about 420 parts per thousand, or I'm sorry, parts per million by volume in the atmosphere today. But in the past, when we've had these warm highs, we've also had major concentrations of carbon dioxide in the atmosphere. Some will say, well, what happens is that it's the changes in solar activity, that is the amount of radiation that the sun is giving off and we're receiving. But if you notice here, at about 1960, we find that our temperature has been climbing routinely all the way up, but the solar radiation has remained somewhat the same. In fact, in the last 60 years or so, it's been declining. So it's not that the solar activity is causing this, something else is. And scientists believe that that something else is primarily human activity that's changed. Well, of course, part of this involved in human population. We reached the first billion people on the planet in the early 1800s. And then about 123 years later, we reached 2 billion. 1960 took 33 years, the next billion took 14 years, then 13 years. In 1999, it took 12 years. By 2011, we produced 7 billion people, and it took 12 years, and the last billion was added to the planet in 11 years. All of those people want to live just like you and I do. We don't have the resources on the planet to do that. So something has to give. But because of the massive increase in population, I mean, if you look at your parents' generation, they could easily have been born in the 1920s or earlier. And since then, we've added 6 billion people in the process, all of whom would like to live just like we do, all of whom would like to use the same resources all of us do. What's happened with land change? Obviously, we had, as populations expanded and grew, we wanted more agricultural land, so we converted land use from forests into cropland by and large. And again, much of that took place since the 1960s in comparison to land use change. Land use change began to take place in the 1960s more rapidly than over the past 100 or so years before that, but the combustion of fossil fuels just went skyrocketing. Carbon emissions today from industrial processes, by and large, are restricted to North America, Europe, and Asia. Most of the southern hemisphere does not have much industrial, many industrial processes operating. And so most of the carbon dioxide emissions that are taking place are in the northern hemisphere. If we look at global energy consumption, you'll notice that most of this, again, is from coal, oil, and gas, with lesser amounts in hydroelectric and renewables, the upper two positions here. That has produced an increase in atmospheric carbon, primarily because of the world energy consumption and secondarily because of deforestation as we changed forests into cropland, as I mentioned just a moment. Both are obviously related to population growth, which has been expanding at a very rapid rate. So here, looking at NASA, and part of this information is also from NOAA, 1884 reconstruction was, as you can see, relatively cool. But by 2022, last year, you can see that we had major changes, particularly in the Arctic regions up here, Europe, parts of Asia. All of this area is radically different, as you can see, with up to 2 or 3 degrees Celsius, that's about 6 to 7 degrees Fahrenheit, increase in temperatures across these areas as compared to those same temperatures in the 1840s. Much of that is from actual climate records, that is temperature records collected from these areas, and part of that is also determined from isotope work on the ice sheets and other areas of the oceans. So the global average surface temperatures is heading outside the range experienced by any of us since Homo sapiens were on the Earth. That's in the direction we're moving. What does that mean relative to global sea levels? Well, the mean sea levels, as determined by many scientists in 18 countries, would indicate that by the end of the century, we will probably have close to a meter increase in sea level. Now, I don't know where many of you live, but a meter increase will make storm surges even worse on the areas. In other words, it's not just a meter, but a storm surge of 2 or 3 meters, 10 feet or something like that coming ashore will affect many of the coastal communities of the world. And if tomorrow we looked at where glaciers do, they currently cover about 10% of the Earth's land area and account for about 3% roughly of the Earth's fresh water. If we melt all the glaciers, and I'm not worrying about the little glaciers we're going to see tomorrow, I'm concerned about the Antarctic ice sheet and the Greenland ice sheet. If we melted those instantaneously tomorrow, sea level would rise by 70 plus meters, or about 230 plus feet. Now, this scale of these maps, obviously I can't, if I look at the west coast of the Americas, of California or Mexico, I can't show you the first mile or two inland. But you can see on the east coast of North America, people living in Florida probably should consider moving if that all happened, right? Because they'd be underwater. If you're in South America and the Amazon basin, you're again in a situation where you're going to have a major melting, and also down where we just came from Buenos Aires and these areas down in the southern Brazil and Argentina along the coast. If you're from Africa, you don't escape the problems along the west coast of Africa. Anyone from Europe, Denmark, Netherlands, the lowlands here are all going to be drowned by that. Eastern United Kingdom, pardon me, is not exempt, obviously, and if you're over in China, the whole area of North China will be flooded, as will many of the islands in the coastal areas. Australians, you've got the northern part here and parts down in the south. So all these areas, now it's unlikely that we're going to have that all happen instantaneously, but the point is, as we lose more and more ice, sea level will continue to rise, and coastal communities worldwide will be in difficult situations. What else takes place as we continue to have global warming? Well, the intensity of storms increases. In today's world, represented by the blue line here, you'll see, for example, Category 4 hurricanes are about 71%. They're going to decrease. Well, I guess that's a good thing. The same thing with Category 3, going to decrease. However, Category 5 storms, much more intense forms, are going to increase substantially. And that's as carbon dioxide levels continue to increase in the atmosphere. We're already seeing that intensity increase, whether it be storms in North America, South America, particularly in parts of Asia and Africa. So what about the thinning of the ice sheets? And these are a couple of years old, as you can see, from 2019 in Greenland and from 2020 in the Antarctic. But the Greenland ice sheet is melting all around the exterior here of the ice sheet. And in fact, today there are major rivers flowing on the top of the Greenland ice sheet. In Antarctica, particularly in West Antarctica, the Transantarctic Mountains come through this area here, right in here, separating East Antarctica from West Antarctica. We're on the peninsula here, and you can see there's quite a bit of red down both sides of the peninsula, and then on West Antarctica. So this is an area that's having major melting of the ice. It's also taking place in East Antarctica and a variety of places around the exterior. One of the big problems today in the north is the permafrost. That is the ground that is permanently frozen. Well, actually, it's not just the ground. If you were there and frozen, you're part of the permafrost. And the permafrost goes down quite a number of meters. In the Russian Federation, you can go down 1,500 meters of frozen material. In the north of Alaska and the Beaufort Sea, you can go down about 1,000 meters and still have frozen ground. The surface areas, however, are beginning to melt. As the solar radiation comes in, the active layer, that's the zone that is thawed annually, is getting thicker. When I first worked in the polar regions, North Polar regions in 1960, the active layer was about 2 to 5 centimeters, half an inch to an inch, or 2 inches in thickness. I was last up in those areas 5 years ago, and we now had as much as 2 meters of unfrozen ground before we hit frozen material. What does that mean? It means that most of this material is peat, vegetation, peat. Everyone familiar with that? That's beginning to thaw, and when it thaws, it begins to decay, and when it decays, methane goes up into the atmosphere, one of the major greenhouse gases. So both carbon dioxide and methane are generated as that decomposes, and that active layer continues moving down, and the atmospheric carbon dioxide and methane go up into the atmosphere, and that increases the temperature on the planet. These are the areas that are vulnerable to permafrost melting, and you'll notice I've stuck this in as the northern hemisphere, not the southern. The Antarctic continent is mostly covered with ice at this point, a major ice sheet. The margins account for only 10 to 15%, depending where you are around the margins of the ice sheets in the Antarctic. That is permanently frozen, true enough, but it's insignificant relative to the Arctic zone, which you see is circumpolar, covering the Russian Federation in Northern Europe, and then Canada and Alaska over in the around the Arctic Circle. I guess we'll just leave it at that. So here are some examples of permafrost melting. You can see that you have depressions developing in different areas, coastal zones where the cliffs are thawing and melting and breaking into the sea. And of course, it's changing habitat for a number of animals. In the north, the polar bear, which exists on sea ice, as sea ice is vanishing, their habitat is vanishing. Down here in the Antarctic, these are Adelie penguins in this case, their food sources are moving further south, so they're moving further south. or losing habitat altogether and not having enough food in their areas. And the similar things are happening in Alaska and the Russian Federation, northern Scandinavia, that have large reindeer herds, and so on. So let's take a look at the global warming map of temperature anomalies against the average temperature in degrees Celsius from 1951 to 1980. And I want you to particularly look at the three areas I have marked there. That was the warming in 2006. This information is primarily from NOAA and NASA. And there we are last year. Dramatic increases in those three areas, which are now up to as much as 4 degrees Celsius in these red areas, 4 degrees Celsius, as opposed to somewhere around 0.2 to 0.5, half a degree Celsius, as short a time ago as 2006. So from 2006 to 22, we're talking about those same surface temperatures now about 4 degrees, as opposed to they were down in this zone before in 2006, and in 22 last year they were up at about 4 degrees Celsius change in average temperatures. So the average warming that's taken place is projected by the end of the century. At the moment, we're at 1.4 Celsius, the blue line. That's today, as I picked that off from the World Meteorological Organization and the UN earlier this year. And if countries do not act, scientists predict that you're going to could go up as far as 4.5 degrees, certainly 2 degrees Celsius by the end of the century, if not much more. If we follow current policies, we can help reduce that some, and based on the Paris Accords, which you may recall are some years old now, they have not been met, but if we did meet them, we probably still would go slightly above 2 degrees Celsius. 2 degrees Celsius, that's about 5 degrees Fahrenheit, so you can get an idea of that. So what about global warming on agricultural yields? This is a change that's anticipated from 2010 to 2050 based on what's been going on since over the last 10 or 12 years. And this is, the World Bank is keeping an eye on this. And you'll notice the southern hemisphere is mostly affected by this, with crop yields diminishing 20 to, in some areas, as much as 50%. If you're from the northern hemisphere, you're a little better off. If we look at North America, Mexico, and the United States, find that most of the yield is moving north toward Canada. That is to say, they can't grow the same crops in the areas that they currently grow corn, wheat, barley, and so on. It has to move north into the Canadian area. And in Europe, southern Europe, which also grows things like olives and various wines, all of that production is moving north into northern Europe. And then the similar things are happening over in India, which most of India suffers fairly significantly, and the areas up in the northern Himalayas and those zones of Nepal and further into parts of Mongolia, etc., will be doing pretty well. In South America, if you're Chilean, as one of my colleagues is, that's pretty good. Argentina, Brazil are going to have diminution of crop yields by as much as 20%. So what's been taking place? We've obviously already seen changing rain and snow patterns. Our storms are getting significantly stronger. And many of the life cycles and migration and habitats of our animal kingdom have changed. Peter was talking about some of the penguin species that are moving further south, partly because of their food diminishing in their particular areas or moving to different zones because they cannot tolerate increases in water temperatures. And we have more heat waves, and just this last year we reached the highest level since glaciation of global temperatures worldwide. There's less snow and ice, there are more droughts, wildfires, I'm particularly familiar with those, having been in the Arctic this past summer when the Canadian wildfires, and there were 850 or more wildfires going in Canada at the time. And part of that is due to the lack of sea ice in the Arctic Ocean, and I'll talk about that at another time. But California's had many, and the west coast of the United States has had many wildfires as well, and that's also taken place in areas of Europe, and particularly in the Russian Federation. Thawing permafrost, we've already talked about. We're finding that because of the increased temperatures of oceanic waters that the corals are being damaged. They can't sustain life under the slightly increased temperatures. Unlike fish, they're not mobile. Some of the fish species are moving up the coast. Again, this is happening all over the world, but I'll give you an example from the United States. The lobster industry, which used to be quite a large industry in Rhode Island, Massachusetts, obviously in Maine, where it still is. Today, there's no lobster industry in Rhode Island, almost none in Massachusetts. And my Canadian friends are just ecstatic because the lobsters are moving up into the maritime provinces of Canada, and it's changing the entire complexion of the industry. Similarly, on the coast of Massachusetts on Cape Cod, they have had species that have only in the past been found in Florida. The waters are so warm that some of those species are now on the Massachusetts coast. Okay? I'm sorry I don't have an example from South America, but the same thing is happening. Species that were up in Brazil and in the tropics have moved down to southern Brazil and are now appearing to some extent in northern, I'm talking about marine species now, fish in particular and crustaceans, are appearing now in parts of Argentina, along the Argentine coast that we've just been in. And that's because the ocean waters are changing and warming. And while all of that's taking place, the first thing people ask me, who cares? What difference does it make? Well, it makes a difference because the currents control the climate. So many of you are familiar with the Gulf Stream, for example. The Gulf Stream, because of different temperature waters from the Arctic Ocean down the coast of North and South America, east coast of both of those continents, is mixing with the water in the Gulf Stream where it begins, roughly around the equator and slightly south of the equator. That's causing the Gulf Stream to slow down slightly and contract. Instead of being so wide, it's beginning to contract. Who cares? Probably nobody unless you live in Europe. Spain, Portugal, France, the UK, and so on, because that's going to change completely your rather temperate climate to one which may change to much different type of climate. So, a fact. Life on Earth can be recovered from a drastic climate shift by evolving into new species and creating new ecosystems. Humans cannot. That's from the United Nations Intergovernmental Panel on Climate Change just last year. That is 23. Earlier this year. So, is there anything we can do? Well, obviously there are a lot of policy changes that could be made, which I will not go into at the moment, but things that you and I could do are use less air conditioning. You really don't need to have your house always at 70 degrees. I mean, 75 is doable, isn't it? Switch to LED lights, that's a major thing that you could do to reduce the amount of carbon used. Share a ride, walk, use public transportation, stop eating so much and stop eating as much meat. Instead of eating it every day, maybe every other day or once a week or something like that. Major changes in agricultural practices. Agricultural practices today, particularly as we move away from ma-pa farms, mother-father farms, into commercial farms that are using large amounts of fertilizers and pesticides frequently, have destroyed the ecology, the natural ecology of the soil. And what does that mean? It means that what you're eating is not as nutritious today as it was 20, 30 years ago. Let's talk just a minute about the advanced GM crops. It's wonderful. We produced 100 bushels more than we did last year. Last year it was 20 bushels. This year it's 100. I'm just making up the figures. 100 bushels, but you're getting much more. The nutrients that are available are still the same amount. So when you had 5 ears of wheat or barley, as opposed to originally 1, the nutrients are now spread over the multiple group as opposed to the single group. And this multiple group is what we're all eating today, which is different than our parents or grandparents did. Go plastic free. I mentioned the other day the problem with microplastics. Reduce our urge to consume. We don't need to get a new phone every year or a new car every 2 years. I remember when my wife and I were married, we inherited my parents' waffle iron. They were married in the 1930s. That waffle iron continued to work marvelously well up until 96, from 1930 to 1996. Okay, I probably only needed to read electric cord, which I, for some reason, couldn't find any place to replace. Since then, we've had 3 waffle irons. And since 96 to today, I don't think is 60 years, if my math is correct. So at one point, we could build these things to actually last for quite a while, instead of being, as we are today, more or less a throwaway society. Plant 1 billion trees would help. And on that note, I think I'll stop because I'm running out of time here. And thank you very much for your attention. I'll be available in the Gatsby in about 5 minutes if anyone has any questions. Thank you very much.